There we go. Hello and welcome back to Calculus 3, section 11.2, vectors in 3D. So we are upgrading, right? How many dimensions can vector have? As many as we need. So we are focusing on 3D vectors because we live in the 3D space. We are three-dimensional creatures. And we use X, Y, and Z to show three spatial dimensions in which we live. Usually we denote that in a coordinate system like this, the X, Y, and Z. The most important part to understand is that this is an upgrade to your good old X and Y coordinate plane. X and Y coordinate plane still lives, and what you see here is just a positive quarter of the XY plane that you know from before. That's that part. So as you are trying to imagine this coordinate system, you are going to visualize it by using the X and Y plane as the floor of this classroom or the surface of your desk. And the Z-axis is going to be perpendicular to your X and Y plane. So this surface here that I painted green should be the flat surface, whether floor or the desk. And then you can have your Z-axis pointing up. Now, the space is divided into 8 octets. What you see here is just one octet, which is created by all positive axes. But if you think about this and imagine this vector Z poking out of the board towards you, you can see that there are 4 quadrants which will make 4 divisions here, and then behind the board where you have negative Z will be another 4, so you have 8 of them. So 3 planes which intersect, XY plane, XZ plane, and YZ plane, 3 planes that intersect create 8 regions. Earlier we had 2 lines intersect and create 4 quadrants. Now we have 8 octets, which is the division. Now you can also use the classroom to orient yourself. You can put the origin 0, 0, 0 in the corner somewhere, and then run x-axis, y-axis along the other wall, and z-axis up, which will create this room to be only one out of those 8 octets, the positive one, and then realize that there is a classroom on the other side of the wall, there is a classroom on this side, a classroom across, and then below 4 classrooms. Floor is going to be XY plane. Ceiling is also XY plane, but it's not in the 0 position for Z. It is 10 feet taller. So this surface over here is the XY plane. The surface over here is YZ plane, and the surface over here is XZ plane. In the 3-dimensional coordinate system, I will locate 3D points. The point is now given as x, y, z. And if I have, let's say, 3, 5, and 2, I will first find 3 on the x-axis. Then I will draw a parallel line to y-axis and count 5. And then I would draw a parallel axis to z and count 2. And that's the location of the point. So we count 3 down the axis, x-axis, then we draw a parallel line to y and count 5 on that one. And then draw a parallel line to z and count 2 on that one. Now, you know, this picture, so it looks like the point is in the xy plane. It isn't. This point here is in an xy plane. So when you are looking at this, how this point evolved, you start from 0, 0, 0 origin. You get to 3, 0, 0, which is on x-axis. Then you get to 3, 5, 0, which is on xy plane. And then you finally go up to 3, 5, 2, which is in space. You have to be able to locate these points so that you can see what's happening. So now that we maybe, do you want to try and graph one? Excellent. Alex says yes. So how about 4, -2, 6? I'll leave the example visible. So try this one. Would you like to do it on the board since you requested? All right. Then draw Batman. Then draw Batman. let's see what we can do. So there it is. The progression is we start at 0, 0, 0. Then we get to 4, 0, 0, which is on x-axis. Then we go negative y. So if the positive y is to the right, the negative y has to be to the left. So I go negative 2. So this point is 4, negative 2, 0. And then I go up to 4, negative 2, 6 with y. And that's it. The next order of business is to understand basic planes. And I like to just draw the parallel real quick to basic algebra where you learn the linear lines. You learn that y equal mx plus b is some slanted line, right, depending on the slope. But there were two special lines. There was the line y equal some number, let's say d, and that was the horizontal line through number d. And also there was a special line x equals c, which was the vertical line through number c. Observe that these special lines, which are parallel to axes, x and y, only have one variable to describe them. So when we have our y equal mx plus b, which is a slanted line, I have x and y present. But for these special lines, we only have one letter to denote that. Because that's all we need. If the line is going to be horizontal and parallel to x-axis, the only thing that I need is to say what is the number to which it goes on the y-axis. So y is 5. The line will be going through 5 parallel to x. The same happens for x equals to c. We only need one degree of freedom, which is value through which the line will go. We know it's going to be parallel to y-axis. So now we are going to bump that up to 3D and understand that the floor, if we call that xy plane, is on the 0z level. Think of it as a sea level for us to measure everything, and above sea level is the positive to measure the mountains, and then below sea level, right, to measure the depth of the oceans and seas and so on, or Denmark. So now you have level where z is equal to 0, and that's xy plane. So what is the easiest way to describe xy plane? Just to write z equals 0. So maybe I should call them special planes. How do they call them in a book? Simple planes. Because obviously we'll do more complicated planes later. So as I said, if you are going to start thinking about this seriously, you are going to put the 0, 0, 0 origin and the corner. Pick a corner in the classroom. And you will realize that z is equal to 0 because it's 0, 0, 0, right? Z is 0. So xy plane is z equals to 0. Observe that I am moving now on the xy plane, right? And the x and y coordinates are changing now for me. But z is not changing because I'm always on the same elevation, right? So no matter which point I take in the classroom, x and y will be something, unless I'm standing in the corner, then there will be zeros as well. But z is always 0. So that's that one coordinate that can describe the entire plane. You can have whatever the hell you want for x and y, z is pinned to be 0. So I can describe the entire floor, which is the xy plane, as z equals 0. Now what's the equation for the ceiling then? It's parallel to the floor. What's the equation for it? This is clearly 10 feet. Z equals 10. Very good. So if the floor is z equals to 0, the parallel plane, which is the ceiling, is going to be z equals to 10. And what is the equation for the floor of the classroom underneath us? Z equals negative 10. Because there is 10 feet. Each floor is 10 feet, right? So you can think about that as you have these parallel planes, right? And if this is your z equals 0, 1 foot above is z equals 1, z equals 2, z equals 3, and so on. That works for the walls. If that wall over there is xz wall, xz meaning y equals 0, that one is how far apart? Exactly how far apart? Very good. So 2.7. Calculate it last time. Use the tiles up there, guys. It's 2 feet. You guys are thinking we're joking. We're not joking. We're serious about this thing. This is engineering, all right? Here's the tiles. You figure it out, right? So these tiles are 2 by 4. So you can figure out how far out is the wall. Simply count the number of tiles times 2. So it is very easy for us to figure out the base wall. If this is the y-axis, then this wall is y and the z. Y and z is this wall, which means that wall over there is also y and z. Except if this is yz, which will be x equals 0, if this is the papa wall, then that one over there is 30 feet away, and that one is going to be x equals 30. So even in 3D, we get to write x equals 10, z equals 10, y equals 5, but this time around, those are not lines, those are planes, and they are parallel to their original position. So xy plane can be described as z equals to 0, and then any parallel plane will be z equals to some number, let's call it c. And I'm going to group this together. Then I have yz plane, which is described by x equals to 0, any parallel plane will be, say, x equals a. Group those together. And at the end, xz plane will be denoted as y equal to 0. Any parallel plane will be y equals to, let's say, b. You can use any letters you want, I don't care. There we go. So those are the simplest planes. Now we are going to have slanted planes, something that it looks like this, let's say. Now those planes, we'll study that later in a course. Those planes will have equation like, I'm going to erase this, 3x plus 2y minus 4z equals to negative 19. Right? So that's how the slanted planes will look like later. And we are going to use them as tangent planes and approximation and stuff like that. So everything that you did in Calc 1, we're just going to bump it up by a dimension. So that's gone. So that's the simple planes. Now, we also want to calculate the distance between objects. We know that distance in 2D was x2 minus x1 everything squared plus y2 minus y1 everything squared. Distance in 3D will introduce just z into the mix. So that will be our distance formula. Can we have a distance in 4D? Yeah, you just add another one. Let's say W. You can keep adding dimensions to whatever space you need. Sphere. Well, that's a circle bumped into 3D, right? So circle used to be x squared plus y squared equal r squared. Now sphere will be x squared plus y squared plus z squared is equal to, yeah, let's use r squared. We just added that z in. Now you know that you can have them not centered at the origin, right? Remember there was an agent k? It was x minus h squared plus y minus k squared, right? If the center was agent k. Well, you can have a sphere centered anywhere. So we can use a, b, c, doesn't really matter. All right, so here is the problem for you to enjoy. Number 24. It says, find an equation of the sphere Find the equation of the sphere with center at 1, 2, 0, passing through. So this is the point on the edge of the sphere. 3, 4, 5. Very creative. Find the equation of the sphere with center at 1, 2, 0, passing through 3, 4, 5. Are you wanting to do it? Oh. Yeah. Since you're already going, just cycle. It's on the edge of the sphere. Yeah. No, it's a point on the surface. It's a point on the surface. Talk to people. You know people? These things sitting next to you, the people, classmates. Talk. Words. Yeah. You're sitting there. It's like, oh my God, what am I going to do? Maybe someone has an idea. Look at it like it's a regular circle. And then what is the equation? Equals 30? 33? Did you bet your money on it? Yes or no?
Yes.
How much?
$5.
$5?
Venmo?
I'm sorry?
Do you have Venmo?
Do you have what?
Do you have Venmo?
What is that? Something to eat?
Transfer Venmo.
Oh no, I use legal channels usually. No money laundering sites.
So she's right, she gets $5.
No one said that. All right, so let's go. I'm going to draw a sphere and the center, and at the edge of the sphere there's a 3, 4, 5. So what I see here is that the distance between 1, 2, 0, which is the center, and 3, 4, 5, the distance is the radius. So I can figure out the distance between these 2 points using the distance formula. Now the distance formula, so radius will be square root. The distance formula goes 3 minus 1, that's 2 squared, plus 4 minus 2 is another 2 squared, and 5 minus 0 is a 5 squared, giving me square root of 33. So now we have the radius as the square root of 33. The equation will be x minus 1 squared plus y minus 2 squared plus z squared equals to square root of 33 squared gives us just 33. Nice. You get the Trump okay. Oh. All right. Now, there are modifications to this problem. Please don't try to memorize this problem and say, I got Calc 3. Because I can make this interesting. I can give you 2 arbitrary points, and I tell you that those are those create diameter. What now? Distance formula, what do you mean divide in half?
Oh, to find the radius.
Yes, to find, okay, great. So if I give you 2 points in space and I say they're diagonal, right, the opposite ends of the diagonal, not diagonal, a diameter, sure, do the distance formula, whatever you get as the distance would be the diameter, and you cut it in half to get the radius. What do you do for the center? Midpoint formula. You average x's, average y's, average z's. Very good. So you can solve these problems then. Nice. We'll make something spicy. The only thing that is left is actually to talk about what the title is, and that's vectors in 3D. We haven't talked about that yet. So now vectors in 3D. We have the vector u to have 3 components. And I'm just freaked out that this stream is not working. I don't know. Yeah, I refreshed it. So vectors in 3D, we have now 3 components to each vector. Those are x, y, and z. And all of the formulas from 2D transfer over except direction. All right? So to find the magnitude, the length of the vector, we still do the u1 squared plus u2 squared plus u3 squared, the same thing as before to find the magnitude. We can also add vectors, subtract vectors, multiply by a scalar to change their length. All of that stuff still stays the same. So u plus v is going to be vector u1 plus v1, comma u2 plus v2, comma u3 plus v3. U minus v is u1 minus v1, u2 minus v2, u3 minus v3. And c times u is cu1, cu2, and cu3. All of that stays the same. The magnitude stays the same, and the unit vector is, again, the same formula of taking vector u and dividing it by the magnitude, except now, right, you have 3 components rather than 2, so it's just a little bit more annoying to compute, but in general, you got it. The vector u can be represented as u1. Actually, I'm just going to add that here. u1i plus u2j plus u3k, using unit vectors I, j, k as carriers. I added this on the top of the vectors. And I don't think there is anything else. Nope, that's it. That's that stuff, and let's take a look at a few examples. So problem 40. U is given as -2, -3, 0. And V is given as 1, 2, 1. Compute magnitude of U plus 3V.
I read a lot of comics. Can you believe me? BLEUGH. Yeah, if you want to like really enunciate it, add as many H's at the end as possible. Exclamation mark, emoji or two. Maybe that one works got like the doctor mask on it. Like, you know?
All right, so I guess you're done. We have u plus 3v, so that's going to be 1. And then that's 3, and then 3. Is that true? So would that be square root of 19? Good enough? Move along? All right. Nice. All right, let's see how this goes. What is this?
Tablet.
Hold on. X squared plus y squared plus z squared minus 8x plus 14y minus 18z less or equal than 65. It's inequality. Sorry, oops. Larger or equal than 65. This is problem 36 in the textbook.
So it's right the other way. It's the original one. Because that's what we originally had, but then it changed. I have no idea what I'm doing. I mean, oh, maybe.
Well, did he somehow force you to say it?
I didn't say anything. I didn't say anything.
George, what did you say? George.
How's it going, guys? Are you done? What is this?
It's
Some.
maybe it's a beer.
I'll have all kinds of answers, like a bunch of letters and numbers. That's good. I like that. I like that.
It's a bunch of numbers and letters in there.
That is already taken. That answer was already been
Oh,
provided.
come on. Stealing all the good ones. I drew a picture of Batman. Does that mean I don't have to solve this one? He's sad, so we can't just pick up any issue of Batman within the last, 20 years? And that's pretty much it. 30. 75 years. Any Batman comic from the last 75, 76 years.
Just an emotional man with very
When the holster comes for you. Yeah, I have no idea what this is. He says it's a reverse ball.
Reverse.
It's like when you take a ball and suck it.
It's a negative. There it is. It's a negative ball. It's a negative
Never
ball.
heard of that.
It's clearly a 15th dimension existence.
All right, let's take a look at this together. So the core of this problem is here. And we see that we have x squared plus y squared plus z squared, which means this is something related to a sphere. But then we have this part over here, which tells us that we are supposed to do completing the square, exactly. So we're going to do completing the square 3 times, and then condense this into an equation and see what it is. So I have x squared minus 8x as the first thing to do. Then I have y squared plus 14y. And then I have plus z squared minus 18z. Now completing the square, you take half of b. So that's half of 8 is 4. Square that, and you add and subtract. So we have x squared minus 8x plus 16 minus 16 plus y squared plus 14y plus 49 minus 49. And then finally, z squared minus 18z plus 81 minus 81, all of that larger or equal than 65. Now, the first 3 will give us the completed square, which is x minus 4, and we squared, and we have the minus 16 floating about. Then the next 3 are completed square, and these 3 are completed square. So what I have is plus y plus 7 squared minus 49 plus z minus 9 squared minus 81 larger than 65. And I collect all of these extras and move them to the other side. So I get x minus 4 squared plus y plus 7 squared plus z minus 9 squared larger or equal than, looking at this, 212? No. 211. That's good enough. Now, this looks like it's a sphere, right? But this is actually all of the infinity of the outside of the sphere. Inverted ball. It's not inverted.
It's a reverse ball.
Yes. Well, you also, because of the equal sign, you do have the surface of the ball included. So think of let's think of an egg, like the thin shell. Your equation, when you have equal sign only takes into consideration the egg shell. Nothing inside, nothing outside of the shape. Just that thin layer which defines the shape. If you have less than, then it would be all of the inside without the shell. If you have less than equal, it's the inside and the shell. So you think of the, let's say, basketball, it would be the part that you can touch, that's the equal side, and then all of the compressed air inside is less than. All of the outside of the ball is greater than. So this is the outside of the ball given by this centered at 4, negative 7, 9 with a radius of square root of 211. So you can describe this as the outside of the ball centered at 4, negative 7, 9 with the radius square root of 211. Oh, but it's also and the shell. So it's outside of the ball and the shell of the ball. So it's not just the outside because of the equal sign, right? So equal sign is taking the shell, the eggshell, right? And then also all of the outside because it's larger than. Good. That was a cool problem. I promise only to put one of these now, and maybe you'll have to do another one for homework, because down the line in this course you will probably have to compute about 1,500 of these. Find the unit vector for vector PQ, where P is given as negative 3, 1, 0, and Q is given as negative 3, negative 4, and 1. Unit vector. Find the unit vector for vector PQ. So vector is PQ. Is it Q minus P or P minus Q? Q minus P? Yeah. So Q is the terminal. So it's minus 3 minus minus 3 is 0. Minus 4 minus 1 is negative 5. 1 minus 0 is 1. The magnitude of PQ is clearly root 26. And the unit vector PQ will be 0, negative 5 root 26 over 26, and root 26 over 26. That's it. Done deal. Green? Questions, concerns? All right, well, if there is nothing, I'm going to stop the stream. That's for the lecture. We'll talk about